Hello children, today we are going to discuss another concept of set theory, that is practical problems on union and intersection of two sets. So practical problems in the sense the daily life what we are going to face in different kind of situations. So in our daily life we come across different kind of situations. Whenever we have that kind of situations, how to apply union and intersection operations on those situations that we are going to discuss here. So to discuss the problems based on union and intersection of two sets, here you need to know about some formulae. N of A. What is meaning of N of A? When our initial stage, when we are discussing about types of sets, there we have cardinal number of a set. Cardinal number of a set. This is the definition I have given. Cardinal. Cardinal means number of elements which are presenting in the set. N of A, simply we can call it as number of elements in the set A. So what is the meaning of N of A? Number of elements in the set A. That is nothing but called cardinal number of set A, and simply we can read it as number of elements in set A. Now let us see here, we have a few problems and few formulae. To discuss that problem, I need to explain a concept for you. Let us have one Venn diagram. Now this is universal set we have. In this we have two sets. One is set A, another one is set B. Now in set A I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now let us here what are the operations we are doing? Union and intersection of two sets. What are the two sets? We have set A and set B. Now A union B, A intersection B. When we apply union and intersection operations between A and B, what we have? We have A union B and also we have A intersection B. Now number of elements in A. Number of elements in A. What are the elements we have? 1, 2, 3, 4, 5, 6. Total how many elements? A. A means this entire set, this circle indicates set A. What are the elements we have in this set A? Total I have 6 elements. 1, 2, 3, 4, 5, 6 elements. So N of A is equal to 6. Now N of B is equal to B means number of elements in set B. This is the second circle I have. Now in this second circle, how many elements do you have? 5, 6, 7, 8, 9, 10. I have total again 6 elements are there. Now N of A intersection B means intersection. Intersection means what? Common elements. What is the common area we have? This is the common area which I have, and 5, 6. These two elements are there in set A and also there in set B. Number of elements in A intersection B is equal to 2. Now N of A union B. A union means what? Union means together. Now together in this how many elements I have? Together means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Together when we consider these two circles, total how many elements we have? 10 elements we have. Now N of mu means universal set. In the entire rectangular box, how many elements we have? 15 elements we have. So from that Venn diagram, these are the observations we have. Number of elements in A 6, number of elements in B 6, number of elements in intersection 2, number of elements under union 10, and total number of elements in the universal set is 15. Now, what is the relation between all these? Now let us know that n of A union B is equal to n of A plus n of B minus n of A intersection B. This is the formula we have between two sets. Means that number of elements in A union B 10 is equal to number of elements in A 6, number of elements in B 6, number of elements in A intersection B is equal to 12. 10 is equal to 6 plus 6, 12 minus 2. That what happened? 10 is equal to 2, which is a true statement. So this is the formula we have. Means n of A union B, number of elements in A union B. The formula is n of A plus n of B minus n of A intersection B. This is the formula we have. N of A union B is equal to number of elements in A plus number of elements in B minus n of A intersection B. Why we are eliminating n of A intersection B? Means this A intersection B part we are considering when we talk about A, and A intersection B we are considering when we talk about B. Means this is the same area we are considering two times. One in case of A, another one in case of B. The elements 5 and 6 we are considering in set A, element 5 and 6 we are also considering in set B. Means how many times we are considering? Two times we are considering. So to balance it, we need to subtract one time. That is the reason minus n of A intersection B. So this is the formula you need to remember. What is the formula we have? N of A union B is equal to n of A plus n of B minus n of A intersection B. Now from the same formula, we have another concept also. What is that another concept? For example, n of A intersection B is equal to, what is the formula? N of A plus n of B minus n of A union B. This is the another formula which we have. Means that this is the minus term comes this side, plus term goes that side, minus term. So this is formula number 2. Next, for example, when we have two disjoint sets, as in our last class we had a discussion about disjoint sets, overlapping sets, that and all. There is no common part between these two sets, so that these two sets are nothing but called disjoint sets. Now in set A we have 1, 2, 3, 4. In set B we have 5, 6, 7, 8. Now number of elements in A 4, number of elements in B 4, number of elements in A union B 4 plus 4 is equal to 8. So in this case, n of A union B we have a formula n of A plus n of B. This is another formula we have. This is the formula we apply when A and B are disjoint sets. A and B are what? Disjoint sets. Formula number 1. N of A union B is equal to n of A plus n of B minus n of A intersection B. Formula number 2. N of A intersection B is equal to n of A plus n of B minus n of A union B. When A and B are disjoint sets, the formula is n of A union B is equal to n of A plus n of B. N of A plus n of B. This is another concept we have. Now, this is about when we have two sets. When we have two sets. We have another concept also. What is that another concept? When we have three sets. When we have three sets. Very rare we use this concept. Just let us know that. When we have a universal set and I have three sets. Set A, set B and set C. A, B, C. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. When we observe this Venn diagram, this entire circle indicates us set A. This entire circle indicates what? Set A. How many elements do you have? 6 elements. This entire circle indicates us set B. This indicates what? Set B. How many elements do we have? 5 elements. This circle indicates for us set C. This circle indicates what? Set C. How many elements we have? 6 elements. Now this is common part between A and B, so that we can call it as A intersection B. Now this is the portion we call it as common part between A and C. This is nothing but called A intersection C. Now this is the portion we have common part between B and C. We can call it as B intersection C. And this part, when we observe this part, this is nothing but common part between all the three sets. This is the part we have. This is the part we have in set A, we have in set B, we have in set C. This portion is nothing but called A intersection B intersection C. This portion is nothing but called what? A intersection B intersection C. Now, based on whenever we have three sets, what is the formula? Means N of A union B union C is equal to, the formula is N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. This is the formula number 4 when we have three sets. So set A, set B, set C. Whenever you have these kind of sets, now what is the formula for number of elements in A union B union C? Means number of elements in A, number of plus number of elements in B plus number of elements in C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. This is the formula. Now let us check once this formula whether it is true or false based on this Venn diagram. A union B union C. Together all these three sets, how many elements we have? 12 elements I have. In set A, how many elements we have? 6 elements. In set B, how many elements we have? 5 elements. In set C, how many elements we have? 6 elements we have. Minus A intersection B. A intersection B. How many elements? 4 and 5. 2 elements. B intersection C. B intersection C. How many elements we have? 5 and 7. 2 elements. A intersection C. This is A intersection C. how many elements we have? 5 and 6. 2 elements we have. Plus A intersection B intersection C. This is the portion is nothing but called A intersection B intersection C. How many elements we have? Only one element. Plus 1. Now let us verify. That is equal to, all is equal to 6 plus 5, 11, 11 plus 6, 17, 17 minus 12, 15, 15 minus 12, 13, 13 minus 12, 11, 11 plus 1, 12, which is true. So our formula is also true. These are the 4 formulae we need to remember to solve the problems based on practical problems on union and intersection of 2 sets. Our next concept, all we have word problems, all problems related to our regular life. So to solve those problems, definitely we require these formulae. N of A union B is equal to N of A plus N of B minus N of A intersection B. N of A intersection B is equal to N of A plus N of B minus N of A union B. A and B are 2 disjoint sets. N of A union B is equal to N of A plus N of B. When we have 3 sets, N of A union B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. This is the concept related to practical problems on union and intersection of 2 sets. Now let us compare example number 23 from page number 21. The question is given like this: if X and Y are 2 sets such that X union Y has 50 elements, X has 28 elements and Y has 32 elements, how many elements does X intersection Y have? So this is the problem given in sentence formation. This we can convert into mathematical form. Then we apply the formula. Now let us see the problem. Very simple problem, Nana. What is given? Given that. What is given? X union Y has how many elements? 50 elements. Means N of X union Y is equal to 50. X has how many elements? 28 elements. So N of X is equal to 28. Y has how many elements? 32. N of Y is equal to 32. What they are asking to find? Number of elements in X intersection Y. N of X intersection Y is equal to how much? Now, here I know 3 quantities and I need to find the 4th quantity. Now, by observing all these 4, definitely we have to remember one formula. What is that formula? We know that. What is the formula we know? N of X intersection Y is equal to N of X plus N of Y minus N of X union Y. Just now we have seen a formula. Second formula, N of A intersection B is equal to N of A plus N of B minus N of A intersection B. A simple. By applying that formula, very easily we can solve this problem. So now you come to know that what are the importance of the formulae. Unless until you don't know the formula, you can't solve this problem. So try to learn all those formulae, then it is very easy to solve these kind of problems. Now that is equal to N of X. N of X is how much? 28. N of Y is how much? 32. X union Y is how much? 50. That is 60 minus 15, that is equal to 10. Now how many elements does X intersection Y have? 10 elements. So our answer is what? 10. A simple question. They ask me a simple question. How many elements does X intersection intersection Y have 10 elements. This is about problem number 23. Example number 23 from page number 21. Now let us come for example number 24 from page number 22. An interesting concept we have. In a school, there are 20 teachers who teach mathematics or physics. How many teachers? 20 teachers who teach mathematics or physics. Of these, 12 teach mathematics and 4 teach both physics and mathematics. How many teach physics? A simple question. You have to understand. Total there are 20 teachers we have. These 20 teachers may teach mathematics or physics. In that, 12 teachers teach mathematics, 4 teachers teach both mathematics and physics. Now what is the question they are asking? How many teach physics? See here. Let us convert it into a symbolic form so that the concept is very easy for us. Given that N of M indicates mathematics, R indicates union, and physics P is equal to 20. Whenever we have the word R indicates union, and indicates, here we have and indicates intersection. That you need to remember. R is the operation for union and is the operation for intersection. So 20 teachers teach mathematics or physics. So N of M union T is equal to 20. 12 teach mathematics, so N of M is equal to 12. 4 teach both physics and mathematics, means N of M intersection P is equal to 4. Now the question, how many teach physics? N of P is equal to how much? Now again I have 4 quantities. Now by seeing these 4 quantities, very easily we can find. What is that? We know that N of M union P is equal to N of M plus N of P minus N of M intersection P. This is the formula number 1. N of A union B is equal to N of A plus N of B minus N of A intersection B. Now M union P 20, N of M 12, N of P we don't know, N of M intersection P is 4. That implies 20 is equal to 12 minus 4, 8 plus N of P plus 8 comes this side minus. So N of P is equal to 20 minus 8, that is equal to N of P is equal to 12. What is that 12 indicates? How many teach physics? How many are teaching physics? 12 teachers. 12 teachers are teaching physics. This is about the problem. For this, when we want Venn diagram, a simple Venn diagram we can have here. So mathematics and physics. This is M, this is physics. Here total I have 4, and here 8, and here 8. Now you see 8 plus 4 plus 8. Total how much will come? 20. Number of mathematics teachers, how many are they? 8 plus 4, 12. Number of physics teachers, who teach physics, how many are they? 8 plus 4, 12. Now what is this 8? This 8 indicates who teach only mathematics. This 8 means who teach only mathematics. This 8 indicates who teach only physics. This 4 indicates who teach both mathematics and physics. Now this total indicates either mathematics or physics. So different kind of answers are there in this Venn diagram. 8 plus 4 plus 8, 20. 20 gives who teach mathematics or physics, means whole. 8 plus 4, 12. 12 indicates mathematics. 8 plus 4, 12 indicates physics. 8 alone when we talk, 8 gives only mathematics. Only mathematics, we are not teaching physics. This 8 indicates only physics, not mathematics. This 4 indicates both mathematics and physics. This is about example number 24. So, today you just observe that formula, try to learn those formula and practice once again. And practice these example number 23 and 24. In our next concept, we are going to finish our first chapter set theory. Hari Om. Thank you.